Hello everyone, so welcome back again. So let's calculate the clustering coefficient of node B, D and E. So let's see for node B. Okay, so node P, let's write the equation. Okay, so for node B has two more friends, C and D. Okay, so clustering coefficient of node B is he has two friend, 2 times 1 and here 2, and then the value of ei, so the network connection between these two friends, we can see here we have two edge. Okay, so B has these two friends C and D, and here we have actually one connection between C and D. Okay, so 1. So the clustering coefficient of B is 1. Okay, so let's calculate for D. So D has how many friends? B, C, H and E. So B has 4 friends. Okay, so 4 friends, 4 times 3, and so let's find out the value of EI. So B, C, H and E. Between B, C, H and E, how many networks, how many connections are there, how many edges are there? So you can find one, B, C and CH. Okay, so 2. So now this is 1 by 3, 2, 2, 1 by 3. So let's calculate for E. So E has 3 friends, you can see E, D, F and G. Okay, so 3 times 2, 2. And how many edges are between these 3 friends? So you can see there are no edges between these 3 friends, so 0, so 0. Okay, so we can see clustering coefficient of B is 1. So clustering coefficient of D is 1 by 3 and clustering coefficient of E is 0. Okay, so now the question is that we are finding the clustering coefficient. Why we are finding the clustering coefficient? So does that tell anything about the node? Okay, or about the structure? So a clustering coefficient is actually a measure of the degree to which nodes in graph tend to cluster together. Okay, so it tells us the structure of the cluster. That means it's a measure by which we can say that it gives us a degree or measure, we can say that how this graph is tend to cluster together. Okay, now evidence suggests that in most real world network, in particularly social network, nodes tend to create a tightly knit groups characterized by a relatively high density of time. Okay, now this likelihood tends to be greater than average probability of a tie randomly established between two nodes. Okay, so here we can see that B has a clustering coefficient 1. So B is actually, B creates a, B is surrounded by a tightly knit group. Okay, so B doesn't have B has only 2 friends, but all of the friends are actually connected with each other. So B creates a tightly knit groups. Okay, now in contrary, if we look at the node CE has actually, if we look at the clustering coefficient of E has 3 friends. Okay, but none of them actually know each other. Okay, so it means that the, I mean, from the measure of clustering coefficient we can see that now E has these 3 friends but they don't know each other. So that means, so the probability likelihood that's not a very tightly knit groups. Okay, so that doesn't create a very strongly connected group, strongly connected friend group. So if we I mean intuitively, if you can think like that, so let's see, if A has 4 friends, okay, so if this is a very strongly connected group, it is more likely that all of them are going to actually at least almost all of them are going to actually know each other. So this is so the clustering coefficient value is going to be high for a strongly tightly connected group, okay. And the lower value of clustering coefficient says that the group is not that strongly connected. And another empirical study by Bierman and Moody says that teenage girls with low clustering coefficient are more likely to contemplate suicide. Okay, so clustering coefficient is actually, it gives us a idea, it gives us a measure or degree that by it in which extents the nodes in the graph tend to cluster together, okay.